So here's an example of solving two-variable, two-equation systems of equations with inverse matrices. The first step we do is to create the matrix A, X, and B. We see that created here. We have our A matrix, we have our X matrix, our B matrix. Our A matrix is called the coefficient matrix because we pull the coefficient terms from the system of equations and put that into matrix A right there. Our X matrix is actually called our variable matrix because it's merely the variables of our equation, and our B matrix is the constant matrix, which is the right-hand side terms right there. The second step is to calculate the inverse matrix of A. We have the A matrix right here, the coefficient matrix, and the second step is to calculate the inverse of that matrix. So the inverse of the matrix has a number portion, a scalar portion, and a matrix portion here. This is the calculation to get the 1/4 over here. And so it's simply this equation right here. I worked it out just to illustrate it, to see where the 1/4 comes from. And then the other pieces merely come from the A matrix itself. We swapped the A and D terms here. The -2 is placed here, the 16 is placed here. The -9 becomes a 9, and the 4 becomes a -4. Then we just multiply it out one by one, 1/4 times every single element in the 2 by 2 matrix. So this is the inverse matrix that's calculated in step 2, and then in step 3 we solve for x and y. This is the big idea here. X is equal to the inverse of matrix A times the constant matrix B. So we take the inverse matrix that we just calculated and multiply it times our constant matrix here. And when we do matrix multiplication, just as a reminder, this is how it's worked out in detail. The first element here, we take our 4 times -2, that's what we have here, and 9/4 times 8, that's what we have here. We're multiplying the row times the column, the row of this matrix times the column of this matrix. And then for the second element, we do the same exact thing. We multiply the row of this matrix times the column of this matrix to get us this result, and then we solve and simplify. We get 10 and 2 as our final matrix. This is our variable matrix that we just solved. We solved for x and y. X is equal to 10, y is equal to -2. On the next page, I show the answer for problem 31 as well. I don't go through all the steps, but it's all illustrated here in the exact same way.